Understanding Natural Language Processing (NLP) for academic research. Natural language processing (NLP) is a cornerstone of artificial intelligence (AI) that delves into the complexities of human, natural languages to facilitate computer interaction. This innovative field empowers machines to comprehend, interpret, and generate human language, bridging the gap between digital understanding and human communication. As you embark on academic research, understanding NLP can offer valuable insights into its applications, which vary from language translation and sentiment analysis to advanced chatbots. The fascinating complexity of human language, laden with nuances, ambiguities, and cultural context, presents an intriguing challenge for budding researchers in AI. Tokenization is a foundational technique in NLP that involves breaking down text into smaller units, known as tokens. These tokens can be as small as characters or as comprehensive as sentences, making language manageable for computational analysis. For instance, the sentence "AI is transforming the world" becomes "AI is transforming the world." Understanding the grammatical skeleton of language, part of speech tagging assigns appropriate labels like noun, verb, or adjective to words, aiding machines in parsing sentence structures essential for translation and interpretation. In "The cat is sleeping," the is a determiner, cat a noun, and both is and sleeping are verbs. The capacity to identify and categorize specific entities, be it names, locations, or dates, is pivotal to extracting meaningful data. In "Apple is launching a new product in California," NER classifies Apple as an organization and California as a location, proving indispensable in information extraction. Unraveling the emotional tone of text, sentiment analysis classifies text into positive, negative, or neutral categories. For instance, "I absolutely love this product" indicates positivity, which is instrumental in assessing customer feedback and monitoring social media sentiments. Predictions based on language modeling enhance machine capacity to generate coherent text, underlying applications such as text completion and translation. Given "the weather today is," a model might predict sunny or cloudy, reflecting the nuances of language. To refine text analysis, stemming and lemmatization reduce words to their base forms, ensuring consistency across different word variations. For example, running, run, and runs are stemmed to run, while better might be lemmatized to good. Before delving into language analysis, text undergoes preprocessing, transforming raw input into structured data by tokenizing, filtering stop words, and converting into word vectors, the groundwork for algorithms to interpret. Post-preprocessing, feature extraction pulls meaningful data points like word frequency and sentence length, allowing machines to decipher text angles and content meaningfully, laying a pathway for interpretative understanding. NLP models thrive on large datasets, employing machine learning algorithms such as recurrent neural networks, RNNs, and transformers. Through rigorous training, these models discern intricate language patterns, enabling insightful applications across unseen texts. When fully trained, these models excel in predictions and classifications, whether gauging sentiment tones or predicting textual sequences, vital for areas like sentiment analysis or language modeling. NLP's prowess in translation, seen in tools like Google Translate, relies on structural and semantic analysis to bridge language barriers, crucial for researchers navigating multilingual resources. Speech recognition systems, transforming spoken language into text, utilize NLP for efficient voice command interpretation, crucial for interactive applications in research settings. Chatbots, equipped with NLP, offer streamlined interactions by comprehending and responding to inquiries, enhancing support and interaction realms in educational and research environments. NLP algorithms adeptly compress voluminous text into succinct summaries, proving invaluable for researchers dealing with extensive documents or literature. NLP dissects social media sentiments, offering key insights for researchers into public opinions on products, events, or phenomena, influencing strategic decisions and hypothesis development. To maintain communication integrity, NLP techniques filter out spam, discerning legitimate content from undesirable messages, thus enhancing academic correspondences. Research in NLP is laden with challenges like linguistic ambiguity and sarcasm, which demand contextual resolution. Nuances in cultural and linguistic diversity necessitate adaptive models to accommodate various dialects and idioms. Furthermore, data scarcity for low-resource languages presents a significant hurdle, urging innovative strategies to enhance language model training. In conclusion, as students delve into NLP for academic research, understanding these facets deepens comprehension and broadens the applicability of AI technology across different contexts, preparing them for advancements and contributions in this evolving field.